Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. I'm here today with Lesson 2 out of our orange Algebra 1 Saxon book, and we're talking about angles, polygons, triangles, and quadrilaterals today. So the first thing we're going to learn are some vocabulary terms that we need to understand. And when two lines cross, we say they intersect. And the place where they intersect, that little point where they intersect, is called the point of intersection. Then sometimes we have lines that never intersect, and those lines are called parallel lines. And the distance that is the perpendicular distance between each one of those lines would always stay the same, never change. So that is parallel lines and intersecting lines. Okay, so we have some more terminology. Perpendicular lines make right angles with each other. Now, a right angle is 90 degrees. So 90 degrees, when we have an angle that is 90 degrees in the corner here, we put a little box to designate that that one is square. In other words, it would be the corner of a square because it's 90 degrees. And a square has 4 90-degree angles. Okay, so that's just a little reminder to us that that angle is a 90 degree because we put a little square in it. All right, so remember that a perpendicular line is like a timeout signal. You've seen them on football. They go something like that. All right, that's a timeout sign. Those are perpendicular, right? You're just putting that one straight in, and there's a little 90-degree angle there. That's a timeout sign. So we think of that when we think of perpendicular. I think of that a lot. Okay, so a straight angle is 180 degrees. So it's going straight across like a regular line. But if that right there is the angle, it is a straight angle because it is 180 degrees. And in your book, you have this little picture where you have a right angle and another little right angle. And together, the two 90 degrees make 180 degrees. So two rights is one straight. Okay, more terms here. We have two lines intersecting, and these two are equal to each other and large angles. They're bigger than 90. These two are equal to each other and smaller. So the word for a larger than 90-degree angle is obtuse, and the word for a smaller than 90-degree angle is acute. I think of a cute little baby. If you walk up to a baby, you say, "Oh, what a cute little baby." Acute, you can think of as being smaller than 90, and obtuse has the same prefix of a word that means big. Okay, obese and obtuse both mean big. So the ob in front is a clue to what the meaning is of the word. So obtuse, bigger than 90 degrees, acute, smaller than 90 degrees. With these relationships, you can see how they kind of add up together. One right angle is 90 degrees. Two right angles put together would be 180 degrees, or a straight angle. And then if we put 4 of them back to back, like in a circle, we ended up with the 90 and the 90 being 180, and then another 90 and another 90, this direction being 180, and all together, all the way around, is 360 degrees. So we say there are 360 degrees in a circle, and that's being measured from the center of the circle. If you started right there at the center, and then you measured this angle all the way around, it would be 360 degrees. Right, now we're starting to talk about polygons, and polygons mean many angles. So poly means many or more than one, and gonon means angle. So when you put them together, a polygon means an angle, a figure with many angles. And the more formal definition is a simple, closed, flat geometric shape made up of line segments. So a polygon should have no curves. It should be straight line segments only. So what does simple mean? Simple was the first word there, and simple means not this. Okay, these shapes, they are shapes, but they cross over themselves. So any shape that crosses over itself is not simple. So these two would not be simple. This shape is not closed. It has to connect to the original, and that one is not connecting. Therefore, that one would not be a closed shape. Now, a flat shape would mean that you could lay it on the table and it would be flat. Okay, so we know what flat means. We have seen things that have height, and that would not be a polygon. Okay, we can have solids that have the shape of a polygon, but a polygon is a flat figure. And we're going to talk about the line segments in a minute, but anything that has curves would not be a polygon. On page 5, you have a lot of studying to do because page 5 goes through each one of the different names for each polygon that has a certain number of sides and vertices. Now, in a polygon, the number of sides always equals the number of vertices, and a vertex is a corner spot. It is the end point of a line segment that is the side of a polygon. So a single vertex is one of those 3 vertices that a triangle will have. So when we have multiple, we call them vertices. When we're only talking about one, we call it a vertex. So a triangle has 3 sides and 3 vertices. A quad, that's your hint right there. Quad means 4, doesn't it? Quadrilateral has 4 sides and 4 vertices. And the endpoints of the sides are called the vertices, and one of those would be a vertex. So if you look on page 5 of your book, which I am not writing all of this down on a board, you have a polygon with 5 sides is a pentagon, because we know the prefix pent means 5. The prefix hex means 6, so a 6-sided figure is a hexagon. A 7-sided figure is a heptagon. An 8-sided figure, like an octopus, has 8 legs. An 8-sided figure is an octagon. A 9-sided figure is a nonagon. A 10-sided figure is a decagon. An 11-sided figure is an undagon. And a 12-sided figure is a dodecagon. Okay, so they have a very nice little chart here in your book that has all of these listed, and I would study those. Now, they have a name for polygons that get bigger than 12, but it's very easy to remember because they call each polygon bigger than 12 sides a n-gon. So if I wanted to have a polygon with 42 sides, I would call it a 42-gon. If I had a polygon with 100 sides, it would be 100-gon. That would be a lot of sides. 2 more vocabulary words: concave and convex. A polygon that is concave has a cave in it. Okay, can you see here where the polygon goes in on itself? And the definition, the formal definition, if there are any 2 points anywhere in the polygon that in order to draw the line between the 2 points, you would have to go outside the polygon to make a straight line. Then that would be a concave polygon. But most of the polygons that we're going to deal with, and they're going to assume, whenever they say polygon in this book, they're going to assume a convex. Now, anywhere I am on this convex polygon, I could start right here, and I'm trying to draw a line right here. I could do it without going out of the polygon. So over here, I wanted to draw a line. There's no place where I go outside the polygon, and basically you can tell them visually. There's no cave. Here we've got a cave that has a little inward turn there. So that is concave and convex. Now we're talking about some terms that let us know the similarities between triangles. So we've got equilateral means lat means sides. So equilateral means they have the same length of sides. And these tick marks here show that the sides are the same length, but you can tell the angles aren't the same because this one is a pretty wide angle and this one is an acute angle. Okay, so the side lengths are the same, but not the angles. So that would be equilateral. A rectangle is equiangular, which means all the angles are the same, but the sides are obviously not the same. When we have a figure that has all of the sides the same and the angles the same, we call that figure a regular polygon. Okay, so if we had a triangle that had the same sides and the same angles, we would say that's going to be a regular triangle. So we're going to see a picture now that I'm going to get out of your book to help you remember that. So this is a little bit easier to explain. So here, can you see how all of these sides are the same, but the angles are not the same? So this is equilateral polygon. And here they've marked all of the angles the same, but these sides are longer than these sides. So this is an equiangular polygon. And this one, all of the sides, you see the tick marks, and the angles also are equal. Therefore, that is a regular polygon. Down here, we have some special names. A regular triangle is equilateral. We call an equilateral the regular, and we know that it's also got the 60 degrees. And then a regular quadrilateral is called a square. A regular pentagon, we've got a building that's shaped like that, don't we, in our national building. And then regular hexagon has got 6 sides, and all the angles and the sides are equal. So if they call it regular, that means all of the angles and all of the sides are equal, even if they don't mark them. This little segment down at the bottom of page 6 is very important. Here we're talking about special types of triangles. A triangle with one right angle is called a right triangle. An acute triangle has every angle is less than a 90 degree. So all of the angles are acute. Remember, in a triangle, all of the angles must add up to 180. So they're giving you that rule right here. The sum of the measures of the 3 angles in any triangle is 180. If all of the 3 are less than 90, then we call it an acute triangle. If we have one angle that's bigger than 90, then we have an obtuse triangle. And if all of the sides are equal and all of the angles are 60, then we have an equiangular. It's also called an equilateral triangle. The only way that you can have an equiangular triangle is also to have an equilateral triangle. We'll talk more about that rule later. An equilateral triangle is a triangle in which all the lengths of all the sides, all three sides, is equal. Because it is a triangle, it will also have three equal angles. That's true of triangles. It's not true of everything. All other polygons don't follow that rule, but for triangles, if it's equilateral, it is also equiangular. We have a lot of special rules for triangles. So here's an isosceles triangle. An isosceles triangle has two equal sides, and the other one is not equal to either one of those. Equilateral has three equal sides, and scalene has no equal sides. So more terminology to learn. Now look at this rule. It's all in bold. You always want to read everything that's in bold in your Saxon book. The lengths of the sides of a triangle and the measures of the angles opposite these sides are related. In any triangle, the angles opposite sides of equal lengths have equal measures. Also, the sides opposite angles of equal measures have equal lengths. So what they're saying is, because we have these two sides that are equal, that means that the angles that are opposite, so that angle and this angle, will also be equal in measure. Because we have three equal sides in this one, the angles opposite each side will also be equal. And since there's three equal sides, there will be three equal angles. Since this one has no sides that are equal, all of the angles will be different as well. Here we have a missing angle problem. We have three angles, a 30, a 130, and an x. We don't know what the x is, but we do know that our rule is the sum of all the angles must be 180. So if 180 is the sum for all, and I already have a 130 plus a 30, or 160, then I'm going to subtract the 180 minus the 160, and I'm going to find out that x must be equal to 20 degrees, because every triangle has a sum of 180 degree in their angles. This triangle, we are given tick marks here and here. That means that this side is equal to that side. It also means that the angles opposite the tick marks must be equal. So opposite this side is the 50. Opposite this side is the x. So I know that the x and the 50 must be the same, so I'm going to change the x to a 50. So now I've got a 50, 50, and the y, I know that I have 180 degrees in every triangle sum of all the angles. So if I've got 50 plus 50, that's 100. And I need how many more to get 180? I need to subtract the 100 that I have already accounted for, and I get 80 degrees. So y must be 80 degrees, and this x was 50 degrees. In this example, we have an x and a y and a 110. So we also have another hint. We know that this side is 8 and this side is 8. These two sides are the same, then don't the angles opposite them also have to have the same measure? So opposite of this side of 8 is x, and opposite this 8 is y, so x must be equal to y. So we know that. Now we have 110 degrees already accounted for. 180, take away the 110, is going to leave us with 70 degrees that we need to squeeze into these two. And if we're going to take 70 into two equal angles, won't they be 35 and 35? 35 plus 35 equals 70. So angle x is 35 and angle y is 35 because they have to be equal to each other and they have to add to 70. This is the last little bit of this lesson. 2D, we're talking about quadrilaterals. And quadrilaterals are four-sided figures. And these are some special quadrilaterals that we need to know the definitions of. A parallelogram is a quadrilateral that has two pairs of parallel sides. Remember, parallel sides are always equidistant from each other. So that is a parallelogram. And the opposite sides will be the same on a parallelogram, but the angles are not necessarily the same. So parallelogram, opposite sides are parallel. A trapezoid is a quadrilateral that has exactly two parallel sides. The other two are not parallel. A rectangle we're very familiar with. It has four right angles and the opposite sides are equal on a rectangle. And a rhombus has all the sides the same, but the angles are not equal. So we have two opposite parallel on the rhombus as well. So opposite sides are parallel, but the sides are equal to each other. So a rhombus is a parallelogram that has the same sides all the way around, isn't it? And then there's a square, which is the same as a rectangle that has all four sides equal to each other. So those are 5 that we need to know. And here we have a rhombus is an equilateral parallelogram. A rectangle is a parallelogram with 4 right angles. I think we defined them all, so now let's look at our examples. On this one right here, we're to find x. Now, what information did they give us? They've given us a 55 and a 55, and all we have to do is find the missing angle. So, wouldn't we add to 180? So, 55 and 55 is 110. So, 110 plus something is 180, and that would be a 70, right? So, x must be 70. Let's look at this next one and see if we can figure it out. Right? So, we have a 40 and an x and a y. But what is the hint that they give us here? They tell us that these two sides have tick marks, so they are the same. Which doesn't that mean that these two angles must be the same? The angle opposite this tick mark is 40. The angle opposite this tick must also be 40. So we have 40, 40, that's 80. And how many degrees in a triangle? 180. So if these two down here equal 80, then this one must be, that's right, it must be 100. And the last one down there is showing a similar, here we have a 10 and a 10 on the sides, which means that the angle opposite the 10 must be the same as the angle opposite the other 10. So x plus y must be the same. X and y must be the same angle. 112 from 180 is going to be 68. So 68 is what we have left, and these two have to be the same. So wouldn't we split 68 in half and get 34 and 34? So 34 plus 34 plus 112 should equal 180. And we have finished Lesson 2 of Algebra 1. And this is Mrs. A, and may God bless your day.